Hi, in this video we're going to introduce trigonometric ratios. And we use trigonometric ratios when we involve two of the side lengths of a right angled triangle and one of the angles other than this 90-degree angle here. So what we saw in the previous video is how to label the sides of a right angled triangle relative to an angle of interest. Now the angle of interest here is the 43 degrees. It's the marked angle here that's not the 90-degree angle, which is not of interest. And then if we look here, we can see that the two side lengths we're given are the 7 and the y. So these are the side lengths of interest. And how did we label it in the previous video? Well, we could see that this side here seems to be adjacent to, next to this particular angle of interest. So remember, we labeled this as the adjacent. I'm going to put an A in a circle. And the reason I'm putting it in a circle is just to avoid confusing it with this side length here. And then we can see that this side length here, this side here, seems to be opposite the angle of interest. So remember, that's called the opposite side. And I'm going to put an O in a circle again. And although we're not involving it here, this side here is known as the hypotenuse. The hypotenuse is the longest side of a right angled triangle. It's always opposite this right angle. So if I did need to label it, I would put an H in a circle for hypotenuse, but we're not involving this side here because the side length is not marked. So we've got O and A. Now, what trigonometric ratios are a way to relate this angle here with the ratio of these two sides of interest, side lengths of interest. And we have three trigonometric ratios. We've got sine, written sine of an angle. The full version of that word is sine. Then we got cos of theta, and cos is short for cosine. And then finally, we've got tan, and that is short for tangent. So let me explain a bit more how these work. Basically, these trigonometric functions, what they do is they take the angle of interest. So in this particular case, this angle of interest is the theta, and theta is just a Greek letter of the alphabet, and it's particularly used for angles. So don't get scared by the fact we're using Greek letters. Ultimately, it's just a variable, and it's often used for angles. So what these are, there's some kind of magic function that takes an angle of interest as an input, and what it gives you back is the ratio of two particular side lengths. Remember, a ratio is just the relative size of two things, and we can find the relative size of two things by just dividing them. So sine of the angle gives you the relative size of the opposite and the hypotenuse. Cos of the angle of interest gives you the relative size of the adjacent and the hypotenuse, and tan of the angle gives you the relative size of the opposite and the adjacent. And there's a nice way to remember this called SOHCAHTOA, and that's basically just a way to kind of summarize this here. Sine of the angle is the opposite over the hypotenuse, cos of the angle is the adjacent over the hypotenuse, and tan of the angle is the opposite over the adjacent. Now, which of these three are we going to use here? Well, involving the opposite, O, and the adjacent, A. Which one of these three uses O and A? Well, we can see it's this one here. It's a tan of theta, so therefore we are going to use tan. And in the video after, we're basically going to then use this trigonometric equation to then work out what that side length is.